Hello everyone and welcome back to my channel. In today's video, we are going to create a chat application that will allow us to chat with our personal documents or our company document using OpenAI, Pinecone, and LangChain. So let us get started. So in order to build our application, there are several steps involved. The first step will be to use one of the document loader in LangChain. And the type of the document loader depends on the format of our document, whether it is a PDF, Word document, an Excel, or text file. And then the next step, we are going to create our chunk strategy. After that, we are going to split our document into a chunks. And then in the step after that, we are going to embed the chunks into a number vector. Then we are going to save both the embedding and the chunks into a vector store, which in our case, we are going to use Pinecone. And in the final step, we are going to integrate with one of the large language model in order to chat with our documents. For more detailed information about the theoretical part, I have already created an article in Medium, which I will leave a link for it in the description of this video. Now let's start coding our application. Alright everyone, so the first step is to install the required libraries. I have already installed these libraries in my machine. So let's start typing the required library. We have pip install OpenAI, then pip install chain, then install pip install pip install pip token, then pip install PDF. Install Now let's run the code cell. It shows requirement already satisfied. That's because I have already installed these libraries in my machine. I'm going to explain these libraries as we go through this application. The next step is to load the environment, the next step is to load the API keys from the environment variable. As a requirement for this tutorial, you should create an account in OpenAI and generate your own API keys. The same is required also for the Pinecone. You should also create an account in pinecone.io and generate your API keys. After that, you have to store both API keys for OpenAI and Pinecone in the environment variable. I have already explained these steps in my previous tutorial, which I would highly recommend guys for you to watch them. Alright? So let's write the code for loading the API keys from the environment variables. So we're going to say import OS and then from dot environment import load underscore dot environment underscore nv and then load underscore environment true underscore API underscore key. Okay. So let's print API. This is just to test if it is loaded correctly. os.env underscore API underscore key. Make sure it's printed so it is not null. Okay, so this is how we are going to load the API keys from the environment variable. So now let us run this code and check if it will print whether it is true or false. Okay, API key loaded is true. This means that now our OpenAI API key is loaded into the environment variable. In this step, we will write the code to load our private document into LangChain. So this application goal is for us to ask questions about the content of our private data or our private document, which is stored in different formats such as PDF, pandas, JSON file, HTML, or Office documents. As I said in the introduction, LangChain provides document loaders that load the data into documents in the LangChain terminology. I will leave a link to the list of document loader in LangChain in the description of this video. Now let us start writing the code for the function to load our document. And for this application, we are going to write the code for PDF loader and Word document loader as well. So we'll start by, define extract underscore text from underscore document. And this function will take one argument, which is our file. Then we're going to import OS, and then we're going to have name and extension is equal to os.pass.split text file. So by this, now we are going to have the name and extension. Now we will check if extension is equal to .pdf. If it is a PDF file, then we are going to go to LangChain .document loaders module and import by PDF loader. And then we're going to print a message to the user. We're going to tell him that we are loading your file. And then we're going to define a new variable loader, which is equal to by PDF loader of file. By PDF loader file will convert our PDF into an array of document. Okay, and each document will contain the page content, its metadata, and the page number. Alright, so this class allows us to load our local PDF file as well our online PDF file using their URL. Okay, next we'll say else if extension is equal to document, it's a Word document. Then again we're going to go to LangChain and document loader and import document to text loader. Then we're going again to print message to the user that we are loading your file. And then we'll define an object or a variable loader is equal to document text loader to load the file. Else, if the document is neither PDF nor Word, then we will print a message to the user to tell him the document format is not supported by our application. And then we will return none. After that, we are going to define a new variable called data, which is equal to loader.load. Loader.load will return the list of LangChain document. As we said, this document loader will return an array of document, and each document contains the page content, metadata, and page number. And loader.load will return the list of these documents. Okay, one document for each page. All right, and at the end will say return data. And by this we finish creating our function for loading the document. Let's run the code cell. Yes, and there's no error. Okay, so now let us test our function. So we'll say here data is equal to extract the name of the function, and we are going to pass, this is a folder I created in the same directory as this Jupyter notebook, and I'm using a PDF file about the graph neural network. Please feel free to use any local PDF file in your machine. So the file name is gnn.pdf. Okay, so I'm passing this PDF file to the function. Okay, and now the PyPDF loader, as we said before, is going to convert this PDF into an array of documents where each document contains the page content, metadata, and page number. So if we want to see the page content of page 1, we'll say print data 0, which is the first document with index 0, page underscore content. Okay, let's run the cell and test. So this is the content of the first page. All right, and if you want also to print the metadata, we say print data 0 dot metadata and run again. It's working as well. And if we go down here, we see the metadata, and we can see here the metadata of the document, which is page 0, and the source is graph neural network.pdf. Okay, what if you want also to see how many pages are in data? So we'll say print f equal to, we have len of data pages in your data. And if we want to see how many characters in the first page, we'll say the following: f we have also length of data, which page 0, and say page underscore content characters in the page. So let's run this one again. Loading. We have the metadata here. We have 25 pages and we have 4,995 characters in the page. Okay, so this means our function is working as expected. Okay, now let us test our function using a Word file. For this, I'm going to use the same code here, but instead of passing a PDF file, I'm going to pass a Word document. And to make our code look more cleaner, I'm gonna put this at the beginning. Alright. So here, instead of passing a PDF file, I'm passing a Word document. I have one also in the same directory called summary.document. Let's run our code and check. Because this is very small, we have one page in your data and we have 2153 characters in the page, and these are the metadata of our document. Okay, if we go down here, we see here the metadata of our document. So this means our function is working for PDF and for Word document. All right. So far, what we have loaded our custom data, our private file into chain documents. The next step is to split or chunk the document into smaller parts in the context of building related application. But first, what is chunking? Why do we need chunking strategy and splitting the document? Chunking is breaking down large piece of text into small segments, and it is an essential technique that helps optimize the relevance of the content we get back from a vector database. Once later on we use a large language model to embed content, we need to embed any content we index in Pinecone. The main reason for chunking is to ensure that we are embedding a piece of content with as little noise as possible, while keeping it semantically relevant. For example, we index a collection of documents in semantic search. Each document is supposed to contain valuable information on a specific topic. By applying an effective chunking strategy, we can ensure that our search result accurately captures the essence of the user query. If, if for example, our chunks are too small or too large, it may lead to imprecise search result or missed opportunity to find the relevant content. Okay? So let's now start writing the code for the chunking strategy. So we'll have define split underscore text into underscore chunks. And we are going to pass data to it, the list of document chains here, and the chunk size. We are going to say chunk underscore size equal 256 characters. Okay, then we are gonna go to LangChain dot text underscore splitter and import the recursive character text splitter class. After that, we are going to define a variable called chunks, which will contain the list of our chunks, and we are going to call the text underscore splitter dot split documents, and we're going to pass our array of document, and then we're gonna return the chunks. Okay, by this we finish the chunking strategy, splitting the document and creating the function. Now let us test our function. So we'll create a variable called my underscore chunks is equal to split underscore text underscore into underscore chunks. We're gonna call our function and we are gonna pass our data, and after that we are going to print to check how many chunks we have. And if you want to see the content of our first chunks, we'll say my chunk one dot page underscore content. Okay, before that let me just run again the PDF loader to load our PDF document. Okay, again let's go back here and let's run the code cell, and I get an error. I think I have a spelling mistake. I didn't run this code cell. So let's run this code cell and again run this one. Yeah, here I have also a spelling mistake. Put here my chunks. So we have 768 chunks, and the content of the chunks at index 1 is this one. So our chunking function is working as expected also. Okay, now in this step we are going to create a function to calculate the cost of embedding the text in the large language model. And we are going to use a model called text embedding ADA002 to calculate the embedding cost in advance to avoid any surprises on our credit card. And we are going to utilize a tick token library for this. So let's start by defining calculate underscore display underscore cost. We are going to pass here the text. First thing is to import the tick token library, and then we are gonna create a variable called encoding equal to tick token dot encoding for model, and here we are going to use text dash embedding dash data dash 002. But first, what is this model that we are going to use here? Text embedding dash ada dash 002 is a machine learning model developed by OpenAI, and it is actually a part of the GPT model. It is designed to convert text into numerical representation, this is what I mean by embedding, that captures the meaning of the text. And it's important because by converting text into embedding, This model allows computer to understand and process large volume of text efficiently. After that, we are going to define a variable called token, total underscore tokens equal to sum length of encoding encode page underscore content or page in text. Okay, here we are going to iterate through the text collection and calculate the total number of tokens generated when each document page content is encoded using the encoding object. After that, we are going to print to the user the total number of tokens. We have total tokens, total underscore tokens, alright? And then also we are going to print now the cost. We'll say embedding cost in USD is equal to total underscore token divided by 1000 times 0.0004. I'll explain this now. Let me just finish it. And 6F. Alright, let's run the code cell and see if it's working. It's working fine. Here we are estimating the embedding cost in US dollar based on the total number of tokens and using the rate of 0.004 USD per 1000 token. And in the last line, we are printing the total number of tokens and the calculated cost to the user. So in short, or in summary, this function aims to calculate and print the estimated cost of embedding a collection of text document using a specific text embedding model, which in our case, we are using the text embedding ADA 002. Now in this step, we are going to create the embedding function. For this step, as I said at the beginning of this tutorial, you should have registered in Pinecone and create your own account and create the API keys and store them in the environment variable. Alright. Also, please note that on the free account on Pinecone, you are only allowed to create one index. So this function, before embedding an index, it will check if there is an existing index. And if it exists, it's going to delete it, and then we are going to create the new index. Alright? So far, what we have done is just loading our document into LangChain document, and we split them into smaller chunks. Now we will embed the chunks and upload both the chunks and the embedding to a vector database in Pinecone. And the reason for that is for fast retrieval and semantic search. So let's start writing the code. So we'll have define load underscore create underscore embeddings underscore index underscore name and chunks. So this function will take two arguments, the index name or the chunk and the chunks. Okay. First, we are going to import Pinecone library for interacting with Pinecone, and then from LangChain .vector stores, we are going to import Pinecone for working with Pinecone vector stores. After that, we are going again to LangChain to underscore OpenAI and import OpenAI embeddings for creating text embedding using OpenAI models. Alright, then here we are going to define a variable called embeddings, which is equal to OpenAI embedding. Okay, think of OpenAI embedding as a specific translator specialized in working with OpenAI language models. Now here in the next line of code, we are going to connect with the Pinecone library using the generated API keys from our free account and the environment setting to access the data there. Okay, so we'll have pinecone.init going to API underscore keys equal to us dot embark get, and we are going to get the environment value underscore key. Okay, then we're going to environment equal OS and get pinecone underscore environment. If a specific index name, the index name that we pass to this function exists, it's going to load that index. And if it does not exist, then we are going to create it as a new index using the index name passed to this function. Okay, so this function, I changed my mind, it's gonna either load existing index or create a new index. Later on in the next step, we are going to create a function to delete pinecone index. Okay, so here we are going to check if index underscore name in pinecone.list underscore indexes, then we'll say print to the user index underscore name already exists, loading the embedding. Okay, and end equal empty. So, and then we are going to say vector underscore store is equal to pinecone.from underscore existing underscore index this to load from existing index embeddings. Okay, and then we are going to print to the user loading is completed. All right, now else if the index does not exist, then we are going to first print again message to the user that we are going to create the index passed by the to the function index underscore name function. After that, we are going to the pinecone dot create underscore index using the index name, and the dimension is equal to 1536 vector store. Okay, so think of it as a shelf where we are going to store our data. Okay, metric is equal to cosine. Cosine is a special measuring tool used to compare books and find those that are most alike. After that, we are going to say vector underscore store is equal to pinecone dot from underscore documents chunks embeddings index underscore name, and then we'll say print creating index is completed. All right, after that we are going to return the vector underscore store, and by this we have completed this function. So let me just explain it again. This function will check if a specified index name already exists in Pinecone. If yes, it's going to print a message indicating that index exists and loads the index and embedding using pinecone dot from existing index. And if the index does not exist, it's going first to print a message about index creation and create a new pinecone index with a specified index name passed to it. And the dimension, which is 1536, is the number of vector that's going to store. And it uses cosine similarity as well. And then we use Pinecone from document to create a vector store embedding document using the embedding objects and store them in a newly created index. And in the end, we return the vector store object representing the Pinecone index with the loaded or newly created embedding. Let us now run the code cell and make sure it's working. And it's working fine. Now we are going to create a function that will delete an existing index. And the reason for that, as I said, on a free account, you're only allowed to create one index. So for during testing and development phase, we need to test our functions and different documents. So if we have existing index, we are going to delete it first and then create a new index. So let's define this function. We'll have define trove underscore pinecone underscore index and index underscore name by default is equal to all, so that it will delete all existing indexes. All right. And then we are going to import the Pinecone library and initialize Pinecone connection. So we'll have API underscore E is equal to s.environ get Pinecone underscore API underscore key and then environment is equal to os.environment. Okay, anyhow, let me copy and paste it from here. It's easier and faster. Let's see. Alright. We'll check first if index underscore name is equal to all, and then we'll say indexes is equal to pinecone dot list underscore indexes to get the list of indexes, and then we'll say print a message to the user deleting all existing indexes. And then we'll say for index and indexes pinecone delete index. We're going to iterate over every index and delete it. Okay. After that, we'll send a message to the user deleting all indexes is completed. Then here we'll say else if there is a specific index name passed to this document instead of the default value. We are going to also print a message to the user deleting index, and we are going to specify the index underscore name. I'll say end is equal to empty, and then we'll go again to pinecone dot delete index and then the index name, and after it is done we'll say print the user index is deleted. Okay, let us run this function and make sure it is working as well. And it is working. Now in this step we are going to test our code so far. So the first thing is to load our document. So let me go back here a few steps and load our document. I want to copy the code because you already saw how we can do it. So I'm going to copy this and then go back here. First we are going to load the document. Okay, going through this, and let's run the code cell. Loading. Yes, we have 25 page in our data and 4,995 character in the page. Okay, after that, so we are loading the document. Next we have to create the chunks. So if we go back again here to this function, let us copy it, this one, go down here and paste it, and let's run this one. So by this we are creating the chunks, and then now we are going to use the functions that we created and we did test, which is calculating the cost. This is to calculate and display the cost of embedding so that we know how much is it gonna cost us. So in order to do this, we have to do here the following: calculate and display embedding, and we are going to pass to it my chunks. Okay, let's run the code. It's gonna take some time. So we have total token 45,310 and embedding cost in USD is $0.018124. Okay, so we loaded the document, we created our chunk and calculating the cost. Next is to create our index, but to be on the safe side, we will delete all existing index first, and then we are going to create the new one. So here we are going to say trove Pinecone index, and it's gonna take the default value so that it will drop all existing indexes. So let's run the code cell and see. It's gonna take a little bit of time, deleting all existing indexes, and we have to wait till it is done. Deleting all indexes is completed. Now in this step, next step, we are going to create our index. So we'll say here we are gonna give it a name, index underscore name is equal to this function is about graph neural network, so I'm gonna say graph neural network document. Alright, and then I'm gonna say vector underscore store is equal to load or create embedding index, sorry, and I'm gonna pass here the index underscore name and my chunks. This code cell, I'm going to run it now, but it's gonna take some time, so I will pause and show you the result. Okay, as you can see here, I get an error, name embedding is not defined, and I guess I have a spelling mistake here. So for you guys, I want to show you this if you are follow along, so that if you face the same error, what to do. So we'll go back to this function here to create the embedding, and indeed we can see here that I have embedding with triple D instead of double D. So let us run this function again. It's working fine. Again here, in order to test, I have to drop the index because it was in the process. Let's run it again and wait for a few seconds, deleting existing indexes. And deleting all indexes is completed. So now I'm going to create the index again, and I'm gonna pause the video and show you the result. Okay, guys, I want to show you here that our index is created successfully. But before that, I get another error about the number of arguments. And if you get an error, and I'm sure you will get it, this is how to fix it. We go back to the load or create embedding underscore index. You add index underscore name equal index underscore name from here. Otherwise, you will get an error. It was like this. And in order to solve this error, I added the index name. Okay. So with this, we tested our code so far by loading our document into LangChain, split it into chunks, calculating the cost, and then creating our index. Okay, So let's now continue. In this step, we are creating a function to generate answers to questions by using advanced AI techniques. We are going to use GPT-4, which is a powerful language model, in combination with a specialized retrieval that searches through a store of information vectors. The retriever will find the most relevant information to our question, and the GPT-4 helps in formulating a coherent and contextually appropriate answer. With this approach, we are combining the strengths of both retrieval-based and generative AI models, which will provide us with accurate and relevant answers. Alright, so let's start defining our function. So we have define generate underscore answer underscore from underscore vector underscore store, and it takes two parameters. Okay, the first one is vector underscore store, and the second one is the question. Okay, and the vector store, which was the one that we just created in the previous step, and the question will be input from the user. After that, we are going to import the following module from LangChain .chains import retrieval question answer. This is a module from LangChain library specifically designed for retrieval-based question answering. And then next, from LangChain underscore OpenAI, we are going to import chat OpenAI. And this is a module which is used to interact with OpenAI language model such as GPT-4, which we are going to use here. After that, we are going to initialize our large language model. So we'll say LLM is equal to chat OpenAI. We'll specify the model to be GPT-4, -4, and the temperature is equal to 1. Alright. Chat OpenAI will create an instance of the chat OpenAI class. And here we have two parameters. The model is we are going to specify the GPT-4, and we set the temperature to 1, which indicates a higher level of creativity. After that, we are going to create a retrieval object. So we'll say retriever is equal to vector underscore store dot as underscore retriever, okay, and search underscore type is equal to similarity. Similarity indicates that the search will be based on finding the most similar vector or piece of information to the input question. Alright, and then here I'm going to have the search underscore quarks equal to K3. This means that the retrieval will return the top 3 most similar results from the vector store. So we created our retrieval object. After that, we are going to create the retrieval question answer chain. So we will have chain equal to retriever question answer dot from underscore chain underscore type LLM equal to LLM, and then chain underscore type is equal to stuff, retriever is equal to retriever. Okay, so here we are passing the previously initialized large language model, and here we have chain type equals stuff, which is a specific chain type from LangChain, I have already explained this in detail in my previous videos about LangChain. So as I recommend at the beginning of this tutorial, I would highly recommend for you guys to watch these videos as well. And at the end, we are incorporating the retriever setup we have set it up before. After that, we are going to say answer, which is what we are looking for, is equal chain dot invoke and our questions. And we are going to return the answer. So with this, we have created the function that will give us the answer to our question. Let's run the code cell and make sure it is working. And it is working. Now we will create another function or code that will allow the user to continuously send a question to the application and gets answers until he or she send exit or quit. So let's start writing our code. So we'll have here import time. Okay. Time module here is imported, which is used for handling time related tasks, and in this function we are going to use it to create a delay before exiting the application. And then we are initializing the counter to I is equal to 1, and we are going to use it to keep track of the number of a question asked. And then we are going to print a message to the user, please type quit or exit to quit. Now we are going to create an infinite loop to receive input question from the user. So we'll say while true, and then we'll say question is equal to input literal, and then we'll say here question number I, so that okay, yeah, it's correct this way. And then we are going to increment the counter, I is equal to I plus 1. So here we are asking the user to input question, and we are specifying its number, and then we are incrementing the counter. After that, we are going to check if the question is quit or exit to exit the while loop. So we'll say if question dot lower n quit exit, and we'll say print exiting the application. Okay, and then we'll put time dot sleep to allow the reader the user to read the answer, and then we are going to break. Okay, but if the question is not the input entered by the user is not quit or exit, then we are going to get the answer to his question. So we'll say answer is equal to generate our functions that we created before, and we are going to pass the vector store, which we created in the previous step, and the input question from the user. And then we are saying answer underscore content is equal to answer and the result. Okay, and then we are saying print. We are going to print the answer to the user, and we are going to put a new line so that we have each answer in a new line, answer underscore content, printing the answer, and then we'll say, and yeah, and that's it. Okay, let us run our code and check if it's working or not. And if it's working, let us ask some question to the application. So let's run the code, and it's working. You see, question number 1, here we have to type our question, and there's a message, please type quit or exit to quit. Okay, So let us type our first question. What is this document about? Okay, and it's getting the answer. It's gonna take a few seconds. And this is the answer. This document provides enough specification to determine the exact subject but appear to be related to academic research, involved question answering, reasoning across document with graph convolution network. Okay, all right. So our application is working now. We can ask a question to it and it will answer. Okay, and if we type quit here, let's test it. Quit, exiting the application. Let us run the code again and let's ask it what is graph neural network, and we get the answer. Also, please note here you can ask multiple questions at the same time, like this. You can say question 1 and you type your question, and again you type question 2 and answer your second question as well. Okay, so with this code so far we have a very useful application that can be used for real scenarios, but however it lacks memory or chat option. So in the next part we are going to add memory to our application. But what do I mean by that? For example, here we ask what is graph neural network, correct? So if we want to continue our question, let's say can you elaborate more? Elaborate more. You see the answer, it says, I'm sorry, but I need more specific information about what aspect you would like me to elaborate more. Because there's no memory, it doesn't know that I'm asking it to elaborate more about the graph neural network. That's why we need to add memory to our application to provide context to it. Alright, now we will add memory for our application. Okay, so we are going to create a function that will add a memory to our application. The goal of this function is to engage in a conversation with memory, generating answers to questions while maintaining a context of our previous interaction using a conversational retrieval chain model. The function will have 3 input parameters. So let's define this function first. Define conduct underscore conversation underscore with underscore context. So it will take 3 parameters. It will have vector underscore store, our question, and chat underscore history is equal to an empty list. Okay, then we are going to go to LangChain dot chains dot chains and import conversational retrieval chain. Okay, this chain is designed for handling conversational context in retrieval based question answering. And then we are going to from LangChain underscore OpenAI to import the chat OpenAI. Okay, after that we are going to initialize our large language model. We'll say LLM is equal to chat OpenAI temperature is equal to 1. And here when we don't specify the chat model name, it will take by default the GPT-3.5-turbo. Now we will set up the retrieval. So we'll say retriever is equal to vector underscore store as underscore retriever. Okay, search underscore type is equal to similarity. We have already defined this before. Let me just copy and paste it from here. Okay, to save time, avoid any misspelling mistake, and then we'll say our conversational retrieval chain is equal to conversational retrieval chain just to avoid any spelling mistake, dot from underscore LLM, and we'll say LLM and reverb. Okay. This conversational retrieval chain class is used for building conversational retrieval chain from LangChain.chains. It is built on retrieval question answer and it provides chat history. That's why we are going to use this chain, because it is going to provide us with a chat history. After that, here we are going to invoke our chain, to get the result is equal to crc dot invoke, and we will say question is equal to question chat underscore history is chat underscore history. Okay, so here we execute the conversational retrieval chain with the current question and the chat history. This will allow the chain to consider past interactions when generating a response. After that, we are going to update the chat history. So we'll say the following: chat underscore history dot append, and we'll say question result answer. So we are updating the chat history by adding the current question and its corresponding answer. This will help in maintaining the context for future interaction. At the end, we are going to return the result and the updated chat history. So we'll say here return result chat underscore history. Okay, let us run this code cell and make sure it's working. And it is working. And also one note, guys, please, before running this code cell, make sure to type exit in the previous one to avoid the while loop. Okay, to exit the while loop. All right, now let us test this function to make sure it's working as well. We'll say chat underscore history is equal to empty list, and then we'll say question, what is this document about, and then we'll say result, because it will return for us result, and chat underscore history is equal to conduct, and we'll say vector store, our vector store question, and our chat underscore history. And after that, we'll say print result answer, and print also the chat underscore history. Okay, run this code cell again and make sure it is working. Okay, so we get the answer. All right, so now let us test it one more time to check the context. What are the methods discussed and let's run the code cell. And here it understands that I'm asking about the same document, and it shows to me here is the answer. With this, we now have a working chat application with our document, or if you want to call it question answer application, to answer any question about our content or our private document. It uses OpenAI, Pinecone, and LangChain to process large amount of text quickly and efficiently. In real scenarios, this application can save time by quickly finding the information we need without having to search through document or ask our colleague for help. And it also improves accuracy, and we can be very confident that the information we are using is accurate, as the application can understand complex questions and provide quite accurate answer and reduce the cost. At the end, LangChain is a powerful tool that can process large amount of text data quickly and efficiently. In my next video, I will show you how to add and use a web interface for this application using Streamlit. So please don't forget to like and share and subscribe to my channel in order to get notified about my latest videos. And I'm going to leave a link for this Jupyter notebook in the description of this video. Alright everyone, that's it for today's tutorial. I hope you gained new knowledge from it. And if you have any feedback or any question, please leave it down below in the comment of this video. And if you enjoyed this tutorial, of course, don't forget to share, like and subscribe to my channel. See you in the next tutorial.